Looks like I'm recording now. So to illustrate this point of slope at a point coming from the slope of the secant line, I used Desmos and sort of sketched out this whole thing in Desmos. So my challenge to you all would be to see if you can do that. See if you can use Desmos to make something interactive. You would probably want H to be something called a slider. And you're going to need point slope formula, and if this is my function f of x, then this is going to be something like y minus f of a equals mx minus a. So that's my point slope formula, where m is going to be the slope of the secant line, which is f of a plus h minus f of a over h. And if you do all this in Desmos, you'll get that green line, and the moment the green dot lines up with the red dot, in other words, the moment h equals 0, what you're going to get is m is undefined. But you could also just throw up the tangent line in red on Desmos and have a green line correspond to the secant line as a slider. And it's the exact same formula, except if you want the t line, the tangent line, then m is f prime at a, which you can actually just write in Desmos, f prime a, and it'll know. Okay, so whatever. That's enough Desmos talk. Let's do some examples of computing derivatives, and this is where we did not do too much in class. So, all right, let me pull up some stuff that already has things done. Hopefully that works. It doesn't work. That's frustrating. All right. Well, I'll do a few really popular ones. So what we have kind of beaten to death is looking at the derivative of x squared. So I'm not going to do that one. Instead, let's do the derivative of some constant over x, and maybe that constant is 1 or 2 or 3 or pi or -7. It's just some constant number. X is my variable. Okay, so this is defined to be the limit as h goes to 0 of a over x plus h minus a over x over h. This is f of x plus h. This is f of x. All right, and this is equal to, so I need to get a common denominator. So I just continue to write limit because I haven't taken the limit yet. I'm just doing algebra. And how do I get a common denominator? I multiply this by x over x, and I multiply this by x plus h over x plus h. So on top for my first fraction I have ax, and on bottom I have x times x plus h. Minus, and on top for my second I have a x plus h, which, you know what, let's go ahead and distribute that. I have ax plus ah over x times x plus h, and all of that is over h. Alright, so I have a common denominator on top, so I can just do the subtraction going across. Limit as h goes to 0, and remember this subtraction hits both terms. So this ax on top cancels this ax, but I have a negative ah is what's left over. So I have minus ah over x times x plus h over, you can think of it like that, h. And now there's a little rule of fractions, and I hate to say rule because it makes you think that you just have to memorize a bunch of mathematics, but really this is just, if you were comfortable with division, it just falls right out. This is a over bc. So if I have a fraction a over b, and I divide that whole thing by c, I can just write it as a over bc. So that's what I'm going to do now. This is the limit. H goes to 0. And now I have negative ah over x times x plus h times h. And now, voila, the h's cancel. And this is the limit. H goes to 0. Negative a over, and I guess I'll distribute the bottom. There's no need, but sure. X squared plus xh. Okay, h is going to 0, which means x times h is going away to 0. And my final answer, I finally don't need to write limit anymore because I finally have taken the limit, is negative a over x squared. Okay, so in conclusion, the derivative of a divided by x is negative a over x squared. Maybe I shouldn't have used a because I've been using a up here for a point, but this is math. I'm not too, I don't worry about variable names. So how can we use this? So for example, whatever, forks. If I have a curve that looks like, maybe it's 3 over x, so that looks like this. And right here at 1, it's 3. There we go. Then maybe I'm curious, well, okay, what's the slope here? Well, let's call this f of x. We just figured out f prime of x is equal to negative 3 over x squared. The slope at this particular point, this is the slope at x equals 1, so that's going to be f prime at 1, which is negative 3 over 1 squared, which is negative 3. Okay, so the slope of whatever, the slope of the secant line, or tangent line, sorry, at this point, which I need to move this down a little, move this up a little, you get it. That's going to be negative 3. Alright, so that's an example of doing the derivative via the definition and tying it in with this idea of slope at a point. Alright, you can't do this with too many functions. I mean, you can, it just, the algebra gets harder and harder and harder. So eventually, the goal is we're just going to introduce a bunch of results because people have done this before. They've done all this algebra before, and you end up getting a few easy rules to follow. So what this is an example of is actually something called the power rule. And that says if you're taking the derivative of something of the form x to the n, then the answer is n times x to the n minus 1. And for example, e.g., the derivative of 1 over x is the derivative of x to the negative 1. So we need to know rules of exponents. And that's equal to, okay, so you should see this and you should say, my n is equal to negative 1. So I bring down the negative 1 times x to the, and if n is negative 1, then n minus 1 is negative 1 minus 1, which is negative 2. So I have negative 2, which is negative 1 over x squared. Alright, and so that's the power rule, and we've seen this before. Let's just write a few more things down. We have derivative of x squared. We did this one in class. We get 2x, right? Because the 2 became a 1 when I subtract 1. And this also works if you had root x. If I want that derivative, well, that's actually the derivative of x to the 1/2 power. So I bring down the 1/2, and then I have x to the 1/2 minus 1, which is 1/2 x to the negative 1/2, which is, when you play with all the algebra, you get 1 over 2 root x. Okay, so this is not how the derivative is defined. The power rule is not the definition of the derivative. The definition of the derivative is using this limiting procedure. The power rule is a result where you do a bunch of algebra and you realize, hey, wait a second, every time I have a function that looks like x to a power, its derivative ends up obeying this. And you can prove that, but that's not the purpose of this course. Okay, another thing that we need to know is that derivatives are linear, but that's a fancy way of saying something that derivatives, let's say this, distribute over sums. So what do I mean? The derivative of 3x squared minus 7x is equal to, so you can think of distributing this. And furthermore, you can pull out constants, so I can actually write this as 3 times the derivative of x squared minus 7 times the derivative of x. And so suddenly, the power rule combined with this sum rule, I guess is what we'll call this. We'll call this the sum rule. Okay. Lets us do all polynomials now. In fact, even more than polynomials. We'll do another example in a second. So this will become 3 times, and now I have to do this computation. Derivative of x squared, which is 2x, minus 7, and derivative of x. Well, let's think about that. This is x to the 1. So when I take the derivative, the 1 comes down. I have x to the 0, but x to the 0 is just 1, so I have 1 times 1. Okay, so there's 1 here. So the derivative of this function is 3 times 2x, which is 6x, minus 7. And I could just combine everything we just did. I could have the square root of x. Let's do 1 over the square root of x plus, let's say, oh, here, we'll do 10 over, yeah, we'll do something like this. Okay, so now we want to take the derivative of this beast. Well, we only have the power rule and the sum rule, so I had better write this using powers. So I have 10 derivative, and x, so the square root of x on bottom is x to the negative 1/2 plus 3 derivative of x. So I have 10, now I have to do the power rule. Negative 1/2 comes down, x, subtract 1 up top. I'll write it out, write it out, write it out. Minus 1/2 minus 1, that's the new exponent. And there's a multiplication happening here. And here's just 3 times 1. And now I have to clean this all up. I have minus 5, x to the minus 3 over 2, plus 3. Okay, there's a answer for the derivative of this beast. Okay, so the moment we know the power rule and the sum rule, derivatives become way easier to compute because we no longer have to do calculus, right? This isn't calculus, this is just an algorithm that we're following. We're just obeying some rules. Calculus is limits. Calculus is limits. Calculus is limits. All right, what else do I need to talk about? What was on this bullet point? So we've done power rule and linearity. We should talk about second derivatives and convexity. Okay,